Okay, so let's talk about IP version 4, IPv4. This is the addressing scheme that we use so that different machines are able to communicate with each other. Every machine needs a different address. Every machine needs a different number. Imagine you're in a city. The city has a bunch of houses all around. Each of those houses has a different address, so the mailman or mailwoman knows how or where to take the mail to, knows where to deliver the mail. Well, the internet works the same way. We have different unique addresses for each machine in a network and across the internet. And we have packets that are running along the wires or through the waves in the air that are being delivered to the other machines. And we need unique addresses in which to know what packets are going where. We say we got a bunch of machines all sending stuff to different other machines. Those packets need to know where they're supposed to end up, which machine they're supposed to go to. Well, that's what these addresses do. So IP version 4 addresses you've probably seen, or most of you have seen. So I'm going to very quickly create a little notepad thing for you, and I'm going to type out what is a fairly standard or common address that we use on the internet, or not on the internet, I should say, that we use for machines connected to a network. So as you can see, there are 4 different numbers that are decimals. They range between 0 and 255. So each one of these numbers has 256 different possible values. Now, why is that important? That's important because that's not really what's being sent across the wire on Ethernet or in the air on the waves through Wi-Fi. What's being sent are ones and zeros, binary numbers. Even more specifically, pulses of electricity. So if you have a pulse of electricity where the electricity is on, that's a 1. If you have a pulse or a time where the electricity is off, that's a 0. That is how computers talk to each other. At a basic physical level, that's how the information gets transferred back and forth, which is pretty amazing if you think about all the different things that are transferred over the internet. Video, audio, programs. We can actually run programs across the internet, voice, like audio, voice chat, things like that. It's all just a whole bunch of ones and zeros in a certain order. So when getting back to the address here, when I have these 4 different numbers, if I represent these numbers in binary, which is base 2, which I'll show you in just a minute. If I represent these in binary, everything is going to be a 0 or a 1. And we're going to have collections of zeros and ones. And when you line them up, they're going to produce this address here for us. So let's talk about what binary looks like. So binary is ones and zeros. You've probably heard that a lot, but never really looked to see what binary looks like. So if I'm going to build a couple of binary numbers so you can see how they work, I'm not going to spend too much time on this, but it's important to know what it looks like. So if I want to build a 192 as a binary number, the way binary works is similar to the way we're used to a decimal number working. So if I have a decimal number, I have digits 1 through 9, or 0 through 9, excuse me. That's 10 different digits. Once I get to 9, when I move up to the next number, I reset. I go back to 0. But then I add a 1 to the left. So I now have a 1 in the tens place and a 0 in the ones place. That's the way our decimal system works. Well, binary works the same way, except instead of having 10 different digits, 10 different characters, if you will, that represent numbers, we only have 2. We have 0 and 1. And so in binary, I start with 0, I go to 1, and then that's all I get. So when I want to go to 2, I do the same thing that I did up here, except instead of waiting till 9, I just go to 2. So the next thing I'm going to do is go back to 0, just like I did here, and then add 1 to the left. Except in binary, this is not the tens place. In decimal, which is base 10, which is what we use, this is the tens place. That's what decimal is. In binary, this is the twos place, if you will. So these are the ones. I have a 0, I have a 1. And then when I have to flip over and start over again, I have a 0 in the ones place and a 1 in the twos place, which gives us 2. So if I continue in this way, I'll have that, which would then be 3. I have a 1 in the ones place, a 1 in the twos place. 1 plus 2 is 3. Similar to if I did that up here in decimal, I have a 1 in the ones place, a 1 in the tens place. 10 plus 1 is 11. So you see how that works? If I continue along, like once I've done this, I can then go on to the next number, which both of these flip back to 0, and I've got a 1 here. This is the ones place. This is the twos place. This is the fours place. See, it's base 2. Everything is going up by 2. So if we look at all of these, where we have in decimal, we're going to have the tens place, hundreds place, thousands, 10,000, 100,000. Here we are going to have the ones place, 2, 4, multiply it by 2, 8 by 2 again, 16 by 2 again, 32's place. I keep going, 64's place, 128's place. Now, let's stop at 128's place, because that's essentially what we're doing. If I type this out, you can see all of the different places that we have represented so far. Ones place, the twos place, fours place, eight's place, 16, 32, 64, 128. Okay? So, that's not what I wanted to do. If I line these up, you can see where each of these binary digits or bits falls into the number. Oops. Okay, so the 128th place, 64, 32, 16, 8, 4, 2, 1. This, in binary, is representing 128. If I want to represent other numbers, I can simply add 1 to one of these places and add it to 128. So for example, if I have a 1 in the 64th place, I now have a 1 in the 128th place, a 1 in the 64th place. I add them together, and this is going to equal, in decimal, 192. Do you see how that works? So 128th place plus the 64th place, add these together, you get 192. If I had a 1 here, I would add another 4 to all of this, giving me 196. So I don't want this to be an exercise in binary, but what I do want to do is show you what these numbers up here represent. What ends up happening is that these values are translated into ones and zeros. We end up with what we call octets. Each one of these numbers, because it is between 0 and 255, requires 8 binary digits. An octet standing for 8 digits. So each one of these has 8 binary digits, separated by a point, if you will, and that is the IPv4 address that the computer sees. So to give you an example of what it looks like, 192.168, let's see, 3, 4, 5, 6, that's 192.168 would be 124 plus 32 gives us 160. No 16th place, 1/8th place to give us 168. So no 4, no 2, no 1. So that's 168. 0 is pretty easy. 1, 2, 3, 4, 5, 6, 7, 8 zeros. And 1, 1, 2, 3, 4, 5, 6, 7 zeros, and a 1. So this is the binary representation of our address up here. So this is what the computer sees when we are dealing with IPv4 addresses. Now, hold this thought, because we're going to come back to this when we talk about subnet masks in a minute, okay? So let's take a look at what our address on this machine is. So let's go back down to Control Panel, and then into Network and Sharing, and then let's look at our connections. If we look at our connections in Properties, we've got our IPv4 properties right here. Let's look and see what is in here. We'll click on Properties. We have the ability to either obtain an IP address automatically, which is how it's set at first, or we can select a specific address to use, which if I wanted to, for example, I could type in 192.168.0.0.1 and then select other values too if I want. Now, if we want to see what these addresses are, we can use the command line. Now, I know many of you were absolutely thrilled with the command line lab because of the errors in the book. But don't worry about that. For the commands that we're going to be using for networking, they've been around for a very long time. They work. We don't have to worry about mistakes being made. One of the commands that we're going to deal with is ipconfig, short for IP configuration, if I can type. Config. If I type this command, hit enter, this is going to give me my IP Internet Protocol information for this computer, including the address that it's being assigned. So here we see Ethernet 0. That should look familiar because that was, over here, that was the connection that we were using. And then there's some information here we'll talk about later, but right here is our IPv4 address. Notice it's 4 sets of digits between 0 and 255. 192.168.126.140. Okay? Now, there are some basic conventions that go along with the IP addressing schemes that we have. We call them schemes. And that is, there are 5 different classes of addresses. And what we mean by classes are the ways they are used. So let me give you some examples up here. I'm going to erase all this stuff. If I have an address that's between, that's first digit, the first octet up here, is between 0 and 127, we call that a Class A address. Class A addresses were initially given out to large companies. AT&T would have a Class A address, for example. And I'll show you why in a minute, but the short answer is they had a whole lot of addresses that they could use because of the way the addressing scheme works. Now, if we had between 128 and 191, that would be a Class B address. Still a lot of addresses, not as many as Class A. MATC, by the way, has a Class B address. It's 146, I believe. Going further, if we started at 192 and go up to 223, those are Class C addresses. Those you're going to see a lot more commonly. In fact, as you can see, our computer right here has a 192 address. So we have a Class C address for our local machine. Now, the last 2 types of addresses don't get used all that much, or at least not by most people. 224 to 239 is Class D. Class D is very specifically for multicasting. Multicasting is, you've all used this a lot. Multicasting is when you have one source that is broadcasting data to many people at the same time. If you have ever subscribed to any streaming service that streams a live event, you have been part of multicasting. So, for example, if there is a baseball game, since this is baseball playoff season, if there's a baseball game going on and you log in and you're watching the baseball game live, it is being multicast, meaning there is one source, one place that is filming the event, and it is broadcasting it simultaneously to a whole bunch of different machines. That's multicasting. And this range is dedicated to multicasting. The last ones, the 240 up to 255, these are considered reserved. These are Class E. They reserved is either used for possible future classes or research, things like that. You can't use these on the internet. Frankly, you can't use either of these on the internet. Well, you can use multicasting, but as far as what we call routable addresses that can leave your home, go out into the real world, we generally stick with Class A through C. And these are the ones that you're going to see most commonly. Now, with all that said, there are a couple of special addresses that I want to point out. The first one is one where everything is a 255. All 4 255s is something that we call a broadcast address. Broadcast address is something that is done internally in local networks to broadcast to every device, every machine on the network. It's specifically this address. No computer can have that address. when a broadcast is sent across this address, it then reaches out to everybody in its network. And that's all we'll cover here. I'm not going to go into details about that. That's more of a networking class issue. But be aware that we do have a couple of these reserved or very specific addresses and address ranges. Speaking of address ranges, each class of address has one range of addresses that is used for private addressing. By private addressing, I mean not for the internet, as in it doesn't leave your network. Or if it does leave your network, no one's going to take it. And there's a reason we do this. We do this because these addresses can be reused inside private networks. As long as they don't leave to go out to the internet, we can all have essentially the same types of internal private addressing. So for Class A addressing, the 10.0.0.0 up to 10.255, of course, 10.255.255.255. That whole range of addresses, any of those addresses are private. I can't spell. This is why it's better to have a whiteboard and be in front of students rather than trying to do this in a video on the internet, but there you go. This is a private Class A address. For Class B, the address scheme is 172.16.0.0 up to 172.31.255.255. And not equals, I'll fix that in a second. That's private Class B. That's a private Class B address. Now, for a private Class C address, because there is an A and a B, so there might as well be a C, that's 192.168.0.0 up until 192.168.255.255. That's the private Class C. So these three ranges, when we use them, they work internally. They work for a private local network. They will not work on the internet. So again, if we look at the address that has been given to this machine, you'll notice 192.168.126.140. That falls in this range. That is a private address. And that is my private address scheme for these machines, for these virtual machines that I'm working with. Now, the way these networks are built is that they are designed to have one section, one portion of the address be what's called the network portion, and one section called the host portion. The network portion is the left part of the address. Depending on the class, it's a different number of these octets, different number of these digits. The right half is the host address. And the way this works is the left half is essentially the larger network identifier. And the host is more of the specific machine. So here as an example, if I live in a city, I have specific streets. Those streets have houses that have numbers on them. Think of the network section of your network, of your address, as being the city. Network is the city. The host is the actual street address of the house. In our network, this is going to be the actual address of our entire network, the city. And this is going to be the individual machines, the individual devices in that city. So for example, with the 192 address, Class C addresses use the first three first three octets to identify their network. So for our current address right here, the network part of our address is 192.168.126. So that's the city, quote unquote, that our computers are living in. The host part is 140. So that is essentially the street address of my computer. It is in this city on this street. There are going to be other machines, like say I have another virtual machine set up. It's going to have the same first three digits. It's in the same network. It's in the same house. We're using the same address. but then the host number is going to be something else, some different number here, because we each have to have our own unique street address so the mailman knows where to deliver the packets. Okay? Class B addresses, they use the first two octets for the network. So for example, 172.16 would be the network portion of the address, where the host might be something like 176.3. These are just numbers I'm making up. But because it falls within this range, it's a private class. This is the network, that's the city, and then this is the street. Now imagine we're in a bigger city, and so now instead of just a street address like in a small town, we have maybe a subdivision or a borough and then a street address inside that. So this is the city, this is the address for Class B. Class A works the same way, except even more so, there's only one of the octets being used for the network side, and then the other three are dedicated to the host side. So 56.198.207, sure. So this is the network, this is the city. So I think of this as Los Angeles. And then this is maybe the North Hollywood section of Los Angeles. This is the eastern side of North Hollywood, and this is the street address, or something like that. Whatever it takes for you to remember that this is a unique identifier for one machine. This is the network that machine lives in. Okay? So, like I said, I don't want to get too deep into this, but I do want to mention what these different classes are. And how we address things. You're going to see these a lot as you start looking at different addressing schemes and different networks that you end up working in. Now, the one last thing I'm going to mention is there are, if you notice here, we have a couple of other pieces to our address. We actually have a number, but let's just start with these two here. We have something called a subnet mask. A subnet mask has the ability to change where the network part ends and the host part begins. Subnetting is the ability to chop up our network into smaller networks, hence subnet, so basically a portion of the network. So for the example, with this network right here, 192.168.126, if I want to chop this up into two different networks for some reason. Maybe I've got two halves of a school and I want one half to be on one side, one half to be on the other. I can do that with a subnet mask. I'm not going into detail about this other than to say this is where binary comes from. If we look at the subnet mask, all of our default masks are a 255 number depending on how many network octets there are. So for a Class C subnet mask, the default is 255.255.255.0. The reason for this is if we look at what that turns out to be in binary, 255.255.255.0, if I do this in binary, I end up with something that looks like this. 1, 2, 3, 4, 5, 6, 7, 8. That's 255. And then 0. So do you see the pattern here? 255 is all ones in an octet. That's the biggest number you can have in our 32-bit system here. And our 8-bit, each 8-bit scheme can only go up to 255. 192 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equals 255. So what matters is you can see these are all ones. A mask, a subnet mask, is something we use to filter our IP address up here. Notice we have a bunch of ones and zeros, we have a bunch of ones. When we use a subnet mask on an IP address, what happens is we do something called ANDing. Won't get into details, but really it means to come up with the actual address, we pass through this and we check to see if these are ones or zeros. If they are both ones, a 1 comes through. If they are not both ones, if one is a 0 comes through. So it's like filtering. Imagine you've got like a coffee filter here, and you're straining this address through a mask here. So this is the filter, this is the coffee. So the only stuff that comes through is a 1 if it's a 1, or a 0 if it's a 0. Okay, so what's going to happen is you are going to see that the subnet mask, when it's the default subnet mask, oops, what did I do? There we go. When it's the default subnet mask, is going to allow the entire address to come through until you get here. I need a 1 and a 0 for this to strain through, to filter through. Otherwise, it's all zeros. What I've done is I've said this is my network, which is true. My network is the 192.168.0 network right here. If I change my subnet mask from the default, if I start adding ones into different places, I start increasing the number of my subnet mask, I'm potentially changing what can be considered the network side and the host side. For every 1 I have in my mask, that 1 is a network, is part of the network side. So that's my default class C. If I put 1 here, if I put a 1 there, now my network extends all the way up to this digit here. So I only have these 7 numbers to work with for my addresses. If that's going over your head, don't worry about it. Don't worry about it at all. You're going to learn a whole lot more about that in other classes. But I wanted to show you what a subnet mask looks like so that when you see 255.255.255.0, you know what it is and at least have an idea of where it's coming from. This is the default subnet mask for Class C. Default subnet mask for Class B is 255.255.0.0 because Class B only the first two octets are being used for the network. For Class A, if you're following the pattern, you're going to see it's going to be just 1. This one here, because Class A only uses the first one, the first octet for their network. So the subnet mask in general, for this class, we're going to leave it as default. So this is what it's going to be for you from now on. Now the default gateway, this is different. The default gateway is the piece of hardware on your system that allows you to get out to the internet. Because your machine, as it is right now, if I have a private address here, my 192.168 addresses, 192.168.0 to up to 255, this address I can't bring out to the internet. It is considered not routable. In other words, I get it out to the internet. It's like inner office mail. It's like if I have this address, I'm sending something to room M410 on main campus. So I write on my envelope M410. And oops, if I am in MATC, they know where to go. They know where to put it. If I took that M410 envelope, it was addressed M410, I went to the post office and I tried to mail it, they would have no idea where M410 is. They wouldn't have a clue what I was talking about because it could be any number of buildings that have an M410 address. So these are essentially the M410s, the inter-office, inter-department mail that we use to talk to other machines in our office or in our house or in our building. If I want this to go out to the internet, I have to have a default gateway, a piece of equipment that translates, that converts my address into an address that can work on the internet, that is not one of these private addresses. That is what your router does. When you get a router from AT&T or from Spectrum or Time Warner, wherever they call themselves these days, when you get that router that's what it does. Its whole purpose is to take your traffic, your information, convert it to something that can be sent out to the internet, and then translate it back. When it comes back from the internet, translate it back to the address that it needs then to go back to your machine. So the router itself does this. That is a Cisco discussion for a different class. But for now, you have to know that the default gateway is going to be the address of the router that you are using. Now, in larger buildings, you may have a number of different places you can go to. In your home, you probably only have just the one router that connects to whatever line comes in from outside. It is important to note, though, that you have to have a default gateway if you want to connect to the internet. If you don't have a default gateway, you're not connecting to anything other than your other local machines in your network, other machines in your office, in your home. Okay, and with that, I am done talking about IP version 4 at this point. There are going to be a couple of other things that I will call back to and mention about it, but we're going to continue on in the next video with other utilities that you can use to get information about your network and Windows, and some other important settings that we have not talked about yet here.